Good morning. Myself, Dr. Niranjan R.S., Department of Physics, Government First Grade College for Women, Valanarshipura. Now I am going to present my research paper on measurement of terrestrial gamma radiation level and annual effective dose in and around Nuggehalli Valanarshipura cyst belts, Karnataka State, India. The outline of the presentation is introduction, instrumentation, methodology, results and discussion, and conclusion. What is meant by radioactivity? The radioactivity means the spontaneous emission or disintegration of nuclei of certain atoms with the emission of one or more types of radiation is known as radioactivity. Radiation is a form of energy that can be propagated through material or space in the form of wave or particle. There are two types of radiation, non-ionizing and ionizing radiation. Non-ionizing radiation, these are the electromagnetic waves capable of producing ions while passing through the matter due to their lower energy. Ionizing radiation means it is a type of radiation that is able to disturb atoms and molecules on which they pass through, giving rise to ions or free radicals. Natural background radiation. All organisms, including human beings on this earth, irrespective of the place of stay or occupation, is getting some dose of high energetic radiation, which exhibits all around us, is known as natural background radiation. There are two types of natural background radiation. There are two types of background radiations, that is natural background radiations and man-made radiations. In the natural radiations, we have extraterrestrial and terrestrial. In the man-made, we have nuclear fuel, nuclear power generation, medicine, industry, and etc. This is the decay series of primordial radionuclides of uranium, thorium, and actinium series. The scope of the present study is to the measurement of annual effective dose in the Nuggehalli Valanarshipura cyst belt. The scope of this study is the measurement of natural background radiation is of greater importance and interest in health physics, not only for practical reasons but also for more fundamental scientific reasons. The baseline data of radiation level is anywhere of global essential for assessing the risk caused to the publics and the workers by the indoor and outdoor exposure from natural sources. This is the geological map of the study area, that is Nuggehalli Valanarshipura cyst belt with different locations. Geology of this present study area. The present study lies between the latitudes of 12 degree 37 minutes and 13 degree 23 minutes north, and longitude of 76 degree and 76 degree 53 minutes east. The Nuggehalli cyst belt extends for approximately 60 km strike length and maximum of 2 km wide, having a large and rich pellets of chromite. It comprises of major lithium units of horn-blended schist. Valanarshipura cyst belt is a trident in shape. The belt extends maximum length of 65 km with a wide range of 0.5 km to 3 km, and belt covers an area of 250 square km. Instrumentation. The instrument used in the present study is the Nucleonics UR705. It is a ambient gamma radiation for the measurement of ambient gamma radiation level. It is a detector. This detector is a GM tube based environmental radiation dosimeter scintillator. It is calibrated with cesium 137 source for a known wavelength. It gives the exposure rate, is converted into observed dose rate using the conversion factor of 8.7 nanogray per hour. That is the observed dose rate. Using that observed dose rate, annual effective dose is calculated. The annual effective dose calculated using the observed dose rate using this equation, that is annual effective dose is equal to D into T into OF into OC. The D means observed dose rate, T means time in hours for 1 year, and OF means occupation factor. It is for 0.8 for indoor and 0.2 for outdoor, and Cc is the conversion coefficient, that is 0.7 sievert per gray. The results and discussion. In the results and discussion, we measured at different locations. In the different locations, we get the maximum value and minimum value at some places. It is quoted in this table 1. In this, the total annual effective dose we calculated, we get is The minimum value we get is 0.68 millisievert per year, and the maximum value is 1.62 millisievert per year. The average value is 1.16 millisievert per year. If we compare these values with the world different countries' values of the outdoor observed dose, if we see this, the present study has observed dose rate of 82.65, but other countries, if we look, the Japan it is 53, USA it is 47, and Egypt it is 22, and etc. different countries. In India, Odisha we have 230 nanogray per hour observed dose rate, and in Shumaga we have 177 nanogray per hour. But in our study we get 82.65, which is greater than the world outdoor average observed dose rate, that is 59 nanogray per hour. The indoor observed dose rates varies from 87 to 217.5 nanogray per hour with average value of 154.18. The high observed dose rates are evident in Shravanbelagula, Adichunchanagiri, Sri Jenukalu Siddheshwara Temple, Hirekal Siddheshwara Temple, Ballenahalli and Dandiganahalli. The variation in the indoor observed dose rate is due to the type of the flooring, ventilation and local geology. In contrast, lower observed dose rates has been observed at Doddalli Kavlu, Kaushika and Kumbhenalli. The lower observed dose rate is because of the good ventilation and prevailing local geology in which the soil and rocks contain lower amount of radionuclides. The indoor annual effective dose for the publics of the study area varies from 0.43 to 1.07 millisievert per year with an average of 0.75 millisievert per year. The outdoor ambient gamma radiation level varies from 52.2 to 130.5 nanogray per hour with an average of 82.65 nanogray per hour. High observed dose rates are observed in Shravanbelagula, Adichunchanagiri, Sri Jenukalu Siddheshwara Temple, Hirekal Siddheshwara Temple and Dandiganahalli. The local geology of this area is covered by granitudes having higher amount of radioactive elements. The lower observed dose rates are found in Mavinkere, Doddalli Kavlu, Kaushik and Kumbhenalli, and in the contrast, the local geology of surrounding comprises soil and rocks having lower concentration of radionuclides. The annual effective dose inhaled by the public of this study area varied from 0.26 to 0.6 millisievert with an average of 0.4 millisievert per year. The total annual effective dose varies from 0.68 to 1.62 millisievert with an average of 1.16 millisievert per year. Conclusion. Based on the results obtained in the study area, the following conclusions are drawn. The present study has measured the indoor and outdoor observed dose rates in and around Nuggehalli Valaneshwara cyst belt. High observed dose rates are observed at the locations where granitudes are present. Lower observed dose rates are present at the locations where the ultramorphic and metabasic type of rocks are present. The average observed dose rates in the study area is higher than the global average. The total annual effective dose in the study area were higher than the global average limit. These are the references used in this paper. Thank you.